Let me show you a Python code that can literally save hours of computation time. You don't need to change your stack or install any packages or even write more codes. This trick is hiding in plain sight. And after today you will use it in every single Python project. Let me show you. So to demonstrate the effectiveness of this program, let's write a simple Python code. Let's import time so that we can measure. Let's make a slow function. This could be anything which takes time, let's say an API call or database lookup. Let's simulate it. Let's see, it takes 5 seconds. Right, we'll need to rename the file 01. All right, so we just need to rename the file. Now all it does, it returns, let's say, product of two numbers, just to see the output if it is coming or not. So let's print slow function of 5, and then we'll again print. We will be printing this 2 times, so which means this program will execute in roughly 10 seconds. Let's make it fast so that we don't have to wait. Now let's see, in 2 seconds we got an output. Now in the next 2 seconds we got another output. How can we make this faster? Now imagine if the Python could remember the result automatically without you writing any caching logic. That's exactly what the trick does. So let me introduce you a standard library from functool. It's LRU cache. So from functool, let's import LRU cache, and we'll just need to add this decorator. Let's define the max size, and let's take 128. And now all we have to do is just run this program and see if this time it is faster. Yeah, see, the second execution was really fast, in almost instant. So now it only compute once and reuses the result. This drastically cut down processing time in any, let's say, AI pipeline you are building, or backend system, or API heavy tools. So let's create a real world scenario where an API calling is being done. So let's do one thing. Let me write the code. Let's do another function. Let's from functool import LRU cache, and let's make a Fibonacci sequence. So let's define max size to be none, and let's define fib of n. So if I'm just writing a simple Fibonacci sequence algorithm, so all it does, it gives the sum of Fibonacci sequence, fib of n minus 1 plus fib of n minus 2. So if you know, if you're going to run your computer to find the Fibonacci of 40, it's going to take a lot of time, without caching, because the solution would be OF 2 to the power n, with linear. But doing this way, we will get it very instantly. If you don't believe me, let me comment out. And now let's try. See, it's going to take forever to calculate this. And now let's bring this up again and see this, very instant. So now the multiplying by every slow operation in your code. Imagine loading database access, parsing file, compiling models. You have just learned your Python function into high speed memory efficient machine. So you can also introspect the cache as well. So let me show you a way. So let's print fib dot cache info, and we can also clear your cache. So let's first print it. So it says 0 hit, 0 miss. And now let's print after that. So it says 30 times it was hit, 48 times it was miss, and the current size is 41. So that's how it works. And if you are more interested, you can also clear the cache. Fifth dot clear cache. This way, if you print this time, you will see different statistic. Now you have cleared your cache itself. So next time you're thinking of reaching to Redis, writing your own in-memory cache, or optimizing calls, try this first. It's simple, fast and free, and it's been hiding in the Python standard library the whole time. If this saved your performance, smash that like button, subscribe, share with the one Python dev who's still living in the slow lane. Thank you.